Welcome to Seattle Prepares Disaster Prep Series. 30 minutes, give or take. Try to make this super concise, super practical information. And today's topic, January 8th, is Seattle hazards. So you have to know what you're preparing for in order to prepare smartly. My name is Ann Forrest. Email to get hold of me is seattleprepares@gmail.com. And I'm very glad you're here. This is a fabulous group of folks. Before we start, a tiny bit about me. I am a retired Navy nurse. I did that for 20 years, and then I stopped. I homeschooled for quite a while as we continued to move around the world, and then settled in Seattle. A couple years after I got here, my son went to school and I became a full-time volunteer doing disaster preparedness stuff. So I am a very active volunteer with the Office of Emergency Management here in Seattle. I also very involved with the emergency communication hubs here in Seattle. So I could go on and on about why I like this work. I have a lot of fun doing what I do. Yes, we are recording this class. I said it just a second ago, but I will clean up the recording and post it to YouTube probably Friday-ish. Takes me a little bit of time to clean it up. It will be there if you have to miss a class, and all of the classes will be recorded. I will absolutely send out the slides. I have no problem with that. You will have homework at the bottom of the piece of paper that I sent out today, the PDF. There is a red box and it says homework, and it's just kind of a summary of the stuff I'd like for you to do. It's great that you're here and you're learning about all this. I love that. I think it makes us all feel much more empowered if we have some idea of what to expect. So it's great that you're learning, but you're not doing as much as you can if you don't take the steps and actually do some of the things that I and experts beyond, way beyond me, have recommended. So homework, I'm going to emphasize it every week. If you have any questions, put them in chat. I'll get to them when I can. And if you have any questions that are very specific to you that you don't think would be appropriate or helpful to the whole group, I will ask that you put them in chat or email them directly to me. Don't take up time in class on an issue that you have that is very unique to you. Okay. This is what we're going to go over tonight. Hazards we face in Seattle. Again, you don't know what to prepare for if you don't know what hazards are facing us. We're obviously going to talk about earthquakes because that's a big one for us. So we're going to go through the types of earthquakes. What are the odds of having an earthquake of the kinds that we're talking about? Weirdly, they've been able to calculate that. I think that's fascinating. We're going to talk about tsunamis. I haven't done this before, I don't think, in a class, but I think there's a lot of misunderstanding about tsunamis, and how they might impact us here in Seattle. And then why we prepare. So let's go through Seattle hazards. The information I'm giving you is compiled by the Office of Emergency Management right here in Seattle. Everything I'm showing you is available. Seattle Hazard Identification and Vulnerability Analysis, the SHIVA. They compile this huge document. They get all these experts together and they go, what do we need to prepare for? So this is a list of the top 18 hazards we face in Seattle. You don't need to write this down. This is on the PDF that I sent out earlier today. Top 18. I've been doing this long enough that I've seen a little bit of a shift. Cyber attack kind of goes up one notch and goes down one notch. I think disease outbreaks, I think that might have bumped up from 8 to 7 because of the pandemic. I'm not really sure. So there's a little shifting in this, but for the most part, earthquakes is always on top of our list here in Seattle. Not because they happen very often, but because if they did, it would be a really big deal. If you're prepared for earthquakes, you're really prepared for all of these in yellow. It's a lot of all my infrastructure's down, the power doesn't work, all that kind of stuff. These ones that are highlighted in yellow, they all sort of resemble earthquakes. So the thinking is, let's prepare for an earthquake, the worst possible scenario, and then all these other things we've kind of covered. We've done some of the prep work for these other hazards that we face. So we're going to go back to, I don't know, fourth grade earth sciences class. I don't know where I learned about tectonic plates, but this is why we have earthquakes. The mass continents and everything are sitting on plates, and these plates are moving because underneath them It's so hot, it's molten rock. These plates shift around and bump into each other. That's why we have earthquakes. So the three kinds of earthquakes, and this is not a Seattle thing, it's not a United States thing, it's worldwide. The three kinds of earthquakes throughout the world are, the first one is the subduction zone earthquakes. These are the big ones. All big earthquakes are subduction zone earthquakes. Anything that's like bigger than a 8.0 is probably a subduction zone earthquake. In our area, our subduction zone earthquake is called the Cascadia subduction zone. Other parts of the world that have subduction zone earthquakes, they have different names. Ours is the Cascadia subduction zone. I believe all of the subduction zone earthquakes in the world happen along this ring of fire. So here's North America, Seattle's up here. This is just where there's huge plates that are bumping into each other. So this is where the big earthquakes are. Closer to home, this is the North American plate. So, Seattle's right up here. We are sitting on the North American plate. There's a small plate right here called the Juan de Fuca plate. And then out here is another plate called the Pacific plate. In our area, there's three plates that are kind of floating around. This is Seattle. We're sitting here on the North American plate. This is that small plate in the middle called the Juan de Fuca plate. And then here's the vast amount of the ocean is sitting on top of the Pacific plate. So what's happening is lava, magma, whatever, is pushing up from the ocean and pushing these two plates apart, which is why Japan, over to the west of us, has earthquakes, and why we over here have earthquakes. This Juan de Fuca plate is slowly, slowly, slowly moving to the right, and it is subducting. It is going under the North American plate. It's going under that plate because it has all this water on top of it. It's very, very heavy. So it makes more sense for it to go under the North American plate than on top of. This area right here where these two plates are touching, there is a lot of friction building up. So an earthquake happens when that friction overcomes whatever's holding it in place. That plate, that friction area that I just talked about is right here. So this is the Juan de Fuca plate going under, and this is the North American plate that's just kind of sitting still. There's lots of tension right here. And what happens when that tension gives way is that earthquake. This part that was rising drops suddenly, which is why you get water going everywhere. And this part that was sinking is now rebounding. So there's just big waves, lots of movement. I'm not going to go much more into that. That's a subduction earthquake when these two plates are stuck and they get unstuck. So again, ours is called the Cascadia subduction zone earthquake. It is really long. I think it's 700 miles. It's all the way up here to Vancouver Island, and the southernmost part is Northern California. So really, really long. I just read something the other day that said this isn't necessarily one long, steady fault line. It could easily go in chunks, like a little piece at a time. A little piece slips, but not the whole thing. So they're just learning more and more about fault lines. There we go, 620 miles long. It is capable of a 9.0 earthquake. It is a really strong one. It could be a really strong one. The last eruption was actually January 26th of 1700. Very weird that we know that, but it's a really cool story. That was 324 years ago, I guess. Math might be off now. So it slips on average every 500 years. It doesn't mean we're going to have one every 500 years. It's just if you average it out over a gazillion years, it roughly slips about every 500 years. But sometimes it does it every 200 years, and sometimes it does it every 1,000 years. So are we overdue? No, that is not the right terminology. We are not overdue for an earthquake. It's going to happen when it happens. We're getting smarter all the time, but as far as I know, we cannot predict earthquakes. Maybe in, another 4 years, but right now I don't think we can predict earthquakes. So it is what we call a no notification disaster. It's going to happen when it happens, and it's going to catch all of us off guard. So that's the first one, the subduction zone earthquakes. The second one that we have here is what we call a shallow earthquake, and it literally is shallow. It just means that the crack in the plate or whatever's going on is very close to the surface of the earth. So unfortunately, we feel it a lot because it's so close to us. So a shallow earthquake is a rupture in the tectonic plate. So it's not two plates colliding, it's a rupture in the plate that we're sitting on. The one that we worry about the most here in Seattle is the Seattle fault. So this is a picture of Seattle. Here's the middle of the city. This is basically the Seattle fault. This is that crack in the plate, in the American tectonic plate that is prone to earthquakes. It's prone to giving us grief. So that's the Seattle fault line. Goes right through downtown, across Mercer Island into Bellevue. Unfortunately, it runs right under a really, really populated part of the city. That's a problem. But that is our shallow earthquake that we worry about, called the Seattle fault. The last one is a deep earthquake. Most common, happens all the time, but we don't feel them. And again, it's because they're so deep. They're so far away from the surface of the earth where we live that we just don't feel them as much. Sensors feel them, so we know they're happening, but we don't feel them. We don't get a lot of shaking up here on the surface. The Nisqually earthquake, which many, many people on the call have probably lived through back in 2001, that was a deep earthquake. That was deep and it was actually pretty far away. And I hear a lot of people say, "Oh, I'm not too worried about earthquakes. I lived through Nisqually. My house was fine. My apartment building didn't get too much damage or whatever." That was a really, really mild earthquake compared to what we could experience here. A, because it was deep, and B, because the epicenter was in Olympia. A little bit more about Nisqually quake, 30 miles below Olympia. It was back in 2001. It was a magnitude 6.8, so not an insignificant one, but again, very deep and very far away from the city of Seattle. Magnitude measures how big the earthquake is. Intensity measures how strong the shaking is, depending on where you are. I'm sure Nisqually was very intense down south, not so intense up here because we weren't that close to the epicenter. It only lasted 30 to 40 seconds. In the life of an earthquake, that's pretty short. In general, the stronger the earthquake, the longer it lasts. The stronger the earthquake, the longer it lasts. A very strong 8.9, 9.1 earthquake from the Cascadia subduction zone could last up to 5 or 6 minutes. That is a lot of shaking for a very long time. For us here in Seattle, which is worse, a Cascadia subduction zone earthquake or a Seattle fault line earthquake? Personally, I'm more concerned about the Seattle fault line. The Cascadia subduction zone has the potential to do a lot of damage over a great swath of area, but it's not as directly impactful to Seattle. The Seattle fault line, by definition, is really going to be difficult on our city. This is a chart. Unfortunately, it only goes up to 2021, but I tried to update it and I can't easily find better information. So it's not a very, this isn't gazillions of years. It's 2000 to 2021. But I just put it up here to show people that even though it feels like earthquakes are happening more often, I think it's just because we hear about them. We have better news coverage than we used to. So nothing's really happening. The 6.0 to 6.9s, it's pretty much a steady state. 7.0s to 7.9s, again, pretty steady, under 20 for the most part. And then the 8.0s, it's one or less a year. If the number of earthquakes changes either up or down, does that mean anything? When I wrote this slide, I think there had been like a slew of earthquakes somewhere, and I don't even remember where. And I remember people kind of panicking that, oh my gosh, the earth is getting, more excited. We're going to have more earthquakes. There's fracking. There's all these earthquakes in other places. Oh my goodness, what does that mean for Seattle? From what I could tell, doesn't mean anything. A temporary increase or decrease in seismicity is part of the normal fluctuation of earthquake rates. Does not mean that we're going to have anything very soon. Again, we are not able to predict earthquakes yet. And that's from the USGS. Since about 1900, we average about 16 major earthquakes a year. 7.0 to 7.9 is about 15. And then there's that one really big one. We get about one a year. So, what are the odds of having an earthquake, one of those two big ones in Seattle? So, a subduction zone earthquake, there's a 15% chance in the next 50 years. Don't ask me how they figure out these odds, but the powers that be are doing it. So, good on them. I appreciate it. 15% chance in the next 50 years. A shallow earthquake, that one that, like I said, I worry about the most for the city of Seattle. We don't know. The science is just not there right now to be able to predict. Scientists do not have enough evidence to solidly estimate a probability for recurrence. So we just don't know. I wish we did. A deep earthquake, like a repeat of the Nisqually, there's an 84% chance in the next 50 years. So chances are really high. We're all going to experience a deep earthquake. Hopefully, the epicenter won't be close to us. Hopefully, it's out in the middle of nowhere and nobody gets hurt. But it's going to happen. Let's talk about the risks a little bit closer to home. And when I say home, I mean in the city of Seattle. So there's this tool called the Seattle Hazard Explorer. I gave you the link to it in the notes. It's not the easiest tool to use, I don't think. I'm really comfortable with it, but I jump on it, probably once every couple weeks. It gives you a lot of information about earthquakes, but also other stuff. It's really, really interesting. I would absolutely encourage you to go in there and just kind of explore. I don't no, I don't have a picture of it. I should have taken a screenshot of it. You could actually type your address in and look and see exactly what the hazards are right near you. How much shaking are you going to have where you live? Um, are you in a landslide prone area? Have you had the in this last bottom left one? The red is places that have had landslides, and the green is places that are prone. Super wet soil, some slant to the land, that kind of stuff. Floods, lots of good information on it. It's really a very cool tool. Again, the Seattle Hazard Explorer. I would encourage you to check it out. So I want to address tsunamis. I think there's a lot of misinformation about tsunamis and the impact to us in Seattle. This is just a tidbit of information. A tsunami in a lake or a pond is called a seiche. I think it's an interesting word. The worst tsunami for Seattle would be if we had an earthquake along the Seattle Fault, not the Cascadia subduction zone fault line that's out in the water. And let me show you why. Well, I'll tell you why. It's going to arrive very, very soon. It's minutes, not hours, before we see water rise in Seattle. So it's sooner. And there's just going to be more water because we're closer to the fault line. I'm going to show you two simulations. I gave you the links to both of these. I would encourage you to watch them when you've got some time. I think they're really hard to understand on the first couple passes. So I'm going to try and help you understand it. This is a video with no noise, no sound, nobody's talking, unfortunately, from a Cascadia subduction zone. So again, the earthquake is out in the ocean. So I'm going to start playing the video and then I will stop it when I think they're going to say something or they're going to do something important. The purple is water leaving, not rising. The red is where water rises. If you see purple, it means the water is rushing out. The red is where the water is rising. This is just saying that they didn't simulate anything north of the border of the United States. I'm going to start the simulation now. You can see the magnitude 9 earthquake line there, the Cascadia subduction zone. It slips. And notice how the color that hits the shoreline first is purple. That means the first thing that happens after an earthquake, if there's going to be a tsunami, is the water rushes away from the beach. The water line drops. So the purple is what you would experience on the shore first. Water rushes away from the beach. If you see that, you need to get off the beach. That is a strong sign. That is the sign, other than the shaking, that there's going to be a tsunami. The other thing I want to point out is in the bottom left-hand corner of your screen is the timestamp. We're currently looking at 1 hour, 15 minutes, and 30 seconds. And you can see the purple has made its way through the Salish Sea and is just now starting to hit Seattle. And it is 1 hour and 43 minutes. 1 hour and 43 minutes. And we are starting to see the water level in Seattle drop. The red, which is the sea rise, is starting down into Puget Sound. It's kind of orange there where Seattle is. It's red at the very bottom, like Port of Tacoma, Hood Canal. It's red down there. So if you watch Seattle, it was purple first and then orange, going back to white, purple, and then orange. So waves are coming and going. And we are 4 hours in, 4.5 hours in. The ocean is still upset. We're at 5.5 hours in after the original earthquake. Now, this is the Seattle Fault tsunami model. So again, the Seattle Fault runs right there through the middle of the city. These are the areas, if the Seattle Fault line had an earthquake, these are the areas that are going to feel it. They're going to feel water coming in. More than 6 feet is this really dark color. So you're going to see it here. So I'm going to move to the next slide. This is another tsunami inundation model. Again, I gave you the link. You can absolutely watch it. Let's play this one. So we are really zoomed in on Seattle. The colors are different here. It doesn't mean anything. It's just kind of the white is where you can see some places are starting to really feel the water rising. Speed this up a bit. So here's where these folks are really feeling it. Anything that's close to the water and low lying, they're going to feel this inundation. Why we prepare? A couple statistics. There's about 200 first responders, firefighters, and their medical crew on duty in Seattle at any given time, and that is not going to go up after a disaster. They are going to get tired. Their replacements aren't going to be able to come in. Some of them are going to get hurt. So, what we have on duty when the earthquake strikes is pretty much what we have for a while. So, we need to figure out how to take care of ourselves until the cavalry can come in. Seattle does not have stockpiles of food and water. I won't say they don't have any, but they don't have enough. They don't have a lot. They've tried that in the past. It was a financial and it was just a nightmare. So they do not stockpile food and water. They don't know where to put it. They don't know what area is going to be safe. If the earthquake is strong enough, Seattle will be separated into islands. In the emergency preparedness world, we call it islanding. And every little island, because of bridges or roadways or whatever, overpasses, all these little islands are going to have to kind of take care of themselves. We could be on our own for weeks. The cavalry will come in, FEMA will get here. It's just you can't get to a large earthquake impacted area the next day. You just can't do it. There's not a there's not enough helicopter pads. There's no roads. There's no railway. The airport runway is going to be messed up. It's going to take some time for supplies and people and stuff to get to us. The city has gamed all this out. Seriously, we see it all the time, but no amount of prep or planning can meet everyone's needs right away. There's just not enough resources in the world. No city on earth prepares for big disasters. They try, but you just can't do enough. So your call to action for this week is get other folks here because you're only as prepared as your least prepared neighbor. Commit to getting prepared and then relax. People think I like live and breathe this stuff, and I'm really an anxious person and I'm terrified. And every time a truck goes by on the road, I jump. No, I've gotten myself prepared. I've gotten my family prepared, and then I really don't think about it a whole lot more. So I would encourage you to do that. Sign up for Alert Seattle and Alert King County. Again, both of those are on your homework list. This is how, if communications are working, and cell phones probably will be working, at least in some places, this is how the city will get us information. Boil your water. This hospital's open. This bridge is down. That's how they're going to push out information. So make sure you sign up and get that information now. And, if there's a big disaster, you can customize it really, really specifically. Like, I only want to hear about information near my house or near where I work. I want to hear about traffic accidents. I don't want to hear about traffic accidents. You can make it really, really customizable and helpful to you. Sign up for Smart 911. It's kind of a related program. What happens is if you ever have to call 911, if you have enrolled in this program and given them information, the operator, the 911 operator can, I don't know if I doubt they say it over the radio, but somehow they get that information to the ambulance crew driving up to your home. So I'm allergic to penicillin. I have a big dog who looks scary, but he's not. You can't get into my house from the front door. You have to go around the back. I have COPD. I'm a diabetic, whatever. Tell them the information you want them to have, and they'll have that when they roll up on the scene. So think about signing up for that. Um, if you have any burning questions, please send them to me, seattleprepares@gmail.com. Next week, we're going to talk about a long-term power outage and how to prepare for that. Unfortunately, some of us have had some experience in this recently. There's my email again. I'm going to put these up. If you haven't signed up for Alert Seattle or Alert King County and you have your phone with you, use those QR codes and sign up. And then I'm going to figure out how to take a look at chat, see if there's anybody in. Yeah, Debbie, you asked a really good question. How would you know if it's high enough ground? Don't stop moving. Keep going as high as you possibly can, especially if you're on the coast. If you're on the West Coast, you cannot get high enough. In Seattle, they are working on signage to tell you how far inland in the city you have to go. The general guidance is 4th Avenue. I don't know what that means. I don't know enough about it. Would a Seattle fault quake cause problems in Lake Washington and Lake Sammamish? Yes. Be prepared, not scared. I love that. Somebody asked about what would Lake Sammamish and Lake Washington look like. So think of a bathtub. I'm going to stop sharing. Think of a bathtub. That's what a seiche is. So the water is just going to slosh back and forth in these closed bodies of water. So I don't know how high the water is going to get. I am fairly certain that if you are in a floating home and you are hooked to the dock, I doubt you have enough play in your hoses, wires, whatever, to withstand a really intense seiche. I think there's going to be a lot of boats bumping into each other, a lot of spillage of oil and other chemicals out into the water. So think of a bathtub. Imagine a 3-year-old farting around in the bathtub, splashing around, kicking from end to end to the bathtub. That's kind of what the water does in a lake or a pond. All right. Thanks, everybody. I'm going to go on about the rest of my evening, and I will see you next week.